we will talk about queues in this session. You might have seen queues at various places like bus stop. What is the principle of the queue? The man who enters the queue can enter only from the back end, and the man who leaves the queue for boarding the bus will leave from the front end. And whenever a new entry joins the queue, it can only join from the back end, and the entry can leave the queue only from the front end. Thus we can say that queue works on a FIFO structure. FIFO means first in, first out. That is, the element which joins the queue in the beginning is the one which leaves the queue, is the one which first leaves the queue. Now computer also uses queues for various applications. You might be knowing that today it is a word of networking. We network various computers to share resources. So suppose there are 10 users who are sharing a network and they are sharing a printer. And most of them they give a printing request. The computer server will queue the request of printing, and the order of the printing will be like the one who gives the printing request first will get the printout first, and so on. Now let us see how we can implement queues in computers. In computers, queues can be implemented as an array or as a linked list. In this session, we will talk about queue as an array. Now to implement the queue as an array in C++, we need to declare an array. Let us suppose we are declaring a queue which is storing integer data. So let us create an array, integer array of size 5 say. To further implement the working of the queue, we need two variables. We can call them front or rear to keep track of the position of the queue, to keep track of the beginning of the queue and the end of the queue. The front will store the index number of the beginning of the queue, and rear will store the index number of the last element of the queue. So let us declare two variables, int front, comma rear. Now when I declare an array like this, an array will be created in memory which will have 5 elements from 0 till 4, and two variables, front and rear, will be created in memory. Now in the beginning my queue is empty, so I will initialize both front and rear by the values -1, because you know the array starts from the index number 0. I will initialize both of them by value 1. Now to add the first element to the queue, I need to increment both front and rear by the value 1. Let us see why. When I need to add one element, say 10 to the queue. Now 10 is the one element in the queue, and this is the only element of the queue. So it represents both front and rear of the queue, and it is considered as a special case. So when the very first element is added to the queue, it represents both front and rear of the queue, and in this case both front and rear, they are incremented by 1. So to add this element 10 to the queue, I will increment both front and rear by 1. When I do this step, the front will get value 0 and rear will also get value 0, and I will say a rear equal to 10. When I write this step, the value 10 will be added to this queue, and both my front and rear, they will contain the index number 0, which is the element present in the queue. Now to add the next element in the queue, I need to increment only my rear variable. There is no need to increment the front variable. So to add one more element, say suppose I want to add 20 to the queue, I will increment rear. And again I will say a rear equal to 20. Now my rear will be be incremented by 1 and 20 will be added here to the queue. Similarly, I can add more and more elements to the queue. I will increase my rear by 1 and I can add 30. Again, I can increment my rear by 1 and I can add 40. Again, if I increment my rear, I can add one more element to the queue. Now you can see my array is full. And suppose I want to add one more element to the queue, then what will happen? To add one more element, again I will increment my rear. Now I will check whether my rear is less than the maximum value which can be entered in the queue. See here, the rear is 5, which is greater than the maximum index number which can be entered in the queue. So it will give the condition queue overflow and no more element can be added to this queue. Now let us talk about how we can delete an element from the queue. To delete an element from the queue, I will delete from the front end. Now in this position of the queue, this is my front and this is my rear. Now I can delete only from the front. So to delete an element, I will increment front by 1. I will say front plus plus. When I say front plus plus, my front will be incremented and it will become 1. Now instead of pointing to 0, front will point to 1. Even if the value 10 is written here, we are not bothered about it because we read our queue only from front till rear. So whatever is written before the front is not meaningful. Now to further delete an element, again I will increment my front. If I again increment my front, the value of the front will become 2 and my front will point to this element. To further decrease an element, I will again increment my front and again my front will point to this element. Now my queue is from front to rear, but in my queue there are only 2 elements. If I further decrease one more element, I will increment front and now my front will point to this element. I suppose that all these elements are deleted. Now this is again a special case because as you can see, this is the only element present in the queue and both front and rear they contain the index number of this element. So when front and rear are equal, it means there is only one element in the queue. And in this case, when I delete this element, the value of both front and rear gets changed. And this time to delete this element, I will make both front and rear equal to -1 because after deleting this element, my queue will be empty. So this is how the operations in the queue are performed. Now let us see how I can make a class tag.